Welcome back, friends. It's another very good time we are meeting again. I am Dr. Mlelo, and today we are going to continue with our topic of biochemistry. So if you remember, in the previous session we are discussing regarding monosaccharides, and we are concluding regarding the aldehydes and the ketones. So we discussed about aldehydes and the ketone, and if you remember, utakuwa unajua aldehyde ni kitu gani na ketone ni kitu gani. Kwa leo tunaenda kuendelea kutoka pale kwenye aldehyde na ketone. Leo tunaenda kuanza discussion yetu kuhusu disaccharide. Nakumbuka mwishoni tulikuwa na discuss maswali ya biochemistry machache, lakini swali zaidi utapata kwenye question bank. Sasa tuendelee na disaccharide. Don't forget to share these sessions to different students. Tuna make sure kwamba unapata quality materials and they are described in such a way that you'll be able to answer a lot of questions in your final examination. Kwa hiyo tuendelee na discussion yetu ya disaccharide. Tuendelee na discussion kuhusu disaccharide. Disaccharide ni molecules ambazo zinatokana na combination of two glucose molecules. So a disaccharide, the sugar formed the result of the combination of two monosaccharide sugar. Tukicombine two monosaccharide sugar napata disaccharide. So that means having one monosaccharide and another monosaccharide, combining them involves the removal of water molecule, and this combination of these two monosaccharide sugars involve the removal of one water molecule. It is known as the condensation reaction. Kwa hiyo condensation reaction ni reaction ambayo ina involve the removal of water molecule. Tunakuwa tunaondoa water molecule, so tunapata product ambayo inaitwa disaccharide. So the word di means two sugar molecule, they have joined it to form a disaccharide. Di means two. So the sugar formed the result of the combination of two molecules sugar. They are formed when two monosaccharide they are formed when two monosaccharide, usually hexose, combined by means of a chemical reaction known as condensation reaction. Kwa hiyo hizi zinakuwa zinatengenezwa wakati ambao kuna two monosaccharide zimecombine by means of a reaction known as condensation reaction. This is a very common reaction in the living bodies kwa sababu every two molecules, when they combine, already they involve the release of water molecules. So that's why the condensation reaction is one among the commonest reaction katika living systems. Simply, condensation reaction tunaidefine kama the reaction which involves the removal of water. And always, even the exams inaweza katoka define condensation reaction. It's very easy. Actually, kwa mtu ambaye anashindwa kudefine condensation reaction tunasema hajui kabisa biology. Yani sio tumpe hata max chache. Hajui. Unaona? The reaction which involves the removal of water molecule from the reacting molecules. That is the general definition of condensation reaction. If we be asked to define condensation reaction, maybe based on a certain category, unaona, ndio tunaweza kusema labda condensation reaction katika formation of disaccharide au katika formation of dipeptide katika amino acids. Lakini kama haujakuwa specialized the reaction which involves the removal of water molecule between the reacting substances or between the reacting molecules. So condensation reaction is also known as the dehydration reaction since it involves the loss of water molecule or water molecules. Inaitwa dehydration kwa sababu ina involve the loss of water molecule. Tena kusoma pia katika fats, combination ya glycerol and fatty acids to form the triglyceraldehyde. It is also an example of condensation reaction, but it involves the removal of 3 water molecules at one time. Kwa hiyo hivi ndivyo ambavyo tunaweza kusema kuhusu condensation reaction na kuhusu removal of water molecule. So disaccharide, they have the general formula of C12H22 and O11, C12 H22 na O11 kwa sababu nakuwa remove one water molecule. Example of condensation reaction during formation of disaccharide is shown below. Here we have one glucose molecule, or you can just say one hexose. It has 6 carbon sugar and then another hexose here. The forward reaction is condensation, the backward reaction is hydrolysis. Forward reaction involves the removal of water molecule, which is here, and also a formation of disaccharide. This is the forward reaction, it is condensation. And the backward reaction is hydrolysis. When we be discussing about the enzymes, we discuss the enzyme hydrolase, the enzymes in the category of hydrolysis. They are the enzymes which catalyze the hydrolysis reaction. Kwa katika enzyme Tuna enzyme ambazo zina catalyze different categories of chemical reactions, lakini enzymes ambazo zina catalyze hydrolysis reactions zinaitwa hydrolases. Tutaenda kusoma katika enzymes mwishoni mwa each kipande cha biochemistry. So ninachokisema ni kwamba the backward reaction involves the addition of water molecule to break up disaccharide is known as hydrolysis. Backward reaction which involves the addition of water molecule to break a disaccharide is known as hydrolysis. Hydrolysis is normally done by the enzyme in the organism, but could be done in the laboratory using dilute acids such as HCl. So katika living system, katika body tunatumia enzyme kuweza kufanya hydrolysis reaction, lakini in the laboratory tunatumia dilute HCl. We can heat using dilute HCl, tunapata hydrolysis reaction. Tutaenda kusoma katika food test, baadhi ya food test, mfano wa test for non-reducing sugar, lazima one among the procedure to heat with dilute HCl. Why is it important to heat with dilute HCl? Because dilute HCl inasaidia katika kuvunja dipeptide bond katika sucrose, and hence it makes sucrose a reducing sugar, while sucrose normally is a non-reducing sugar. Kwa hiyo the bond formed between two monosaccharides as the result of condensation reaction is called glycosidic bond. Very important for you to remember glycosidic bond. Yani kama kuna vitu ambavyo nitakiwa ukumbuke ni vile ambavyo vimewekewa bold. Very important for you to remember the bond formed between two monosaccharide molecule is known as glycosidic bond, and is normally found between carbon atoms 1 and 4 of neighboring units. Yani kama it's glucose and glucose, they are combining, that means the carbon number 1 of one glucose and the carbon number 4 of another glucose, they will join to form a glycosidic bond. So normally this bond, because it is formed between carbon number 1 and carbon number 4, it is known as the 1,4 glycosidic bond. We can see an example for 1,4 glycosidic bond or 1,4 glycosidic linkage katika disaccharide huyu hapa. Unaona, this is disaccharide lactose formed from the combination of galactose and glucose. We discussed about the galactose and we saw about the difference between galactose and the glucose. So this is the combination of galactose and alpha glucose to give a molecule of lactose. The molecule of lactose, it has 1,4 glycosidic bond. This is carbon number 1 of galactose and this is carbon number 4 of alpha glucose. It forms lactose. Remember, lactose is the common name which we use, but the IUPAC name of this molecule, it is galactosyl beta 1,4 or 1,4 glucose. Galactosyl beta 1,4 glucose. Always in biochemistry you find these common names like lactose, but also you find these IUPAC names which they are naming according to the bond and the nature, how the molecule they have joined. So don't worry about this, and usio worried kwamba inakuaje. No, just ignore this. Wewe nenda tuna jina lactose, ilo jingine galactosyl beta 1,4 glucose. You can't be asked it in your exam for your level. So hii process ambayo inakuwa inafanyika ili kuweza kutengeneza disaccharide can be repeated several times. Yani tukicombine one sugar molecule and another sugar molecule to form a disaccharide, we can get another sugar molecule, and then we can continue combining, getting a very long sugar molecule having many sugar units. That a molecule having many sugar units, we call it as the polysaccharide. Poly means many. Kwa polysaccharide inakuwa ni molecule ambayo ina sugar units nyingi. Poly means many. So nachokisema ni kwamba the process can be repeated many times to build up the giant molecule of polysaccharide. So polysaccharide ni combination of many glucose molecule. Many glucose molecule, they form a polysaccharide. They form a polysaccharide. So nachokisema ni kwamba the monosaccharide units are called residue once they have been linked. Monosaccharide units, they are called residue once they have been linked. Kwa tukishazunganisha monosaccharide units tunazipa jina, zinakuwa zinaitwa residue. Kwa hiyo kwa mfano a disaccharide, it contain only 2 residue. Polysaccharide, it contain many residue, usually from 40 to etc. Na always ni kwamba for your level msomi, lakini Tukicombine 2 sugar molecule tunapata disaccharide. From there, having 3 sugar molecule to 10 sugar molecule, we always call it as oligosaccharide. So oligosaccharide sugar, it may have 3, 4, 5, 6, 7, 8, 9 sugar units. We call it as oligosaccharide. But for your level, you don't study about oligosaccharide. From disaccharide, we directly study polysaccharide. However, katika levels of organization, tukitoka disaccharide huwa naenda kwenye molecule ambayo inaitwa oligosaccharide. So the most common disaccharide which we discuss, tuna maltose inayotokana na combination of glucose, lactose and sucrose. So we have maltose, lactose, sucrose. All of these 3 disaccharide ndizo ambazo tutakuwa na discuss katika discussion yetu. Maltose, lactose pamoja na sucrose. Sasa hizi disaccharides zina different properties na zinatumika for different uses in the body. Unaona, zinatumika kwa matumizi mbalimbali katika mwili wa human being and even in plants. We can start discussing one disaccharide after another. Tuanze na disaccharide maltose. Maltose here hana complication nyingi. Very easy. Maltose, it occurs mainly at the breakdown product during digestion of starch by enzyme called amylase. So tunafahamu katika saliva tuna salivary amylase. Amylase ina digest starch kwenda kwenye maltose, salivary amylase. Na pia tuna pancreatic amylase katika pancreas ambayo ina digest starch pia kwenda kwenye maltose. Kwa katika human body hatuwezi kutengeneza maltose. Sisi maltose tunaitoa katika end product of digestion of food. Now this commonly occurs in animals and in germinating seeds. Katika mbegu ambazo zinakuwa zinaota pia maltose inakuepo katika mbegu ambazo zinakuwa zinaota. Now I'll explain one phenomenon to you which will be very enjoyable, more especially kama umekulia mazingira ya kijijini. You'll enjoy this phenomenon. I hope you'll enjoy it because the first day I knew it, I enjoyed it. So I will explain to you. Just stay tuned, you'll enjoy the phenomenon. So tunachokisema ni kwamba maltose inapatikana kwa animals, tunaipata endapo tukidigest starch katika either saliva au katika pancreas. Lakini kwa plants wanaipata maltose kama kwenye germinating seeds. Germinating seeds, mbegu zinazoota zinakuwa zina maltose. Now the latter is made use in brewing beer. Brewing beer, viwanda vya kutengeneza pombe. Brewing beer. When barley grain, barley ni nafaka. Barley grain is used as the source of starch. Unaona, wanapokuwa wanatengeneza bia wanatumia nafaka, ngano au shayiri. Ngano au shayiri wanatumia kama source of nini? Of starch. Kwa hiyo wanachokifanya ni kwamba wana stimulate the process of malting. Wana stimulate the process of germinating of that barley grain. And when they start germinating, that means they convert starch which is stored in them into maltose. And that maltose is then later fermented by yeast to release alcohol. Unaona, is then later fermented by yeast to release alcohol. So germination of barley is stimulated, and this results in the conversion of starch to maltose, a process known as malting. So ukiambiwa write short notes about malting. What is malting? Yani unajua kwenye biology nishakwambia kuna maswali ya short notes. What do you understand by? What do you understand by? It's not necessarily what we define. Unaelezea unajua nini kuhusu malting. Malting is the process of conversion of maltose of starch into maltose. This normally occurs in plants during seed germination. It is made use in brewing industry to produce beer. The maltose used is fermented by yeast. Yani, just write the information you know about that something you have been asked. Umeulizwa nini kuhusu hicho kitu? Write the information you know kuhusu hicho kitu. So the maltose is then fermented by yeast to alcohol. Maltose is fermented by yeast to alcohol. Inakuwa fermented na yeast. Tunafanya fermentation hiyo maltose kwenda kwenye alcohol. So maltose is formed when 2 alpha glucose units. Okay, I forget to explain you the phenomena. The use of malting and the germination of seeds, germination of the barley grains, seeds katika kutengeneza beer pia inatumika even in villages. Okay, kama umekulia kwa vijijini popote, any region Tanzania umekulia vijijini, I hope you know mataptap, pombe za kienyeji. always wanatengenezea mahindi, lakini kuna wengine nadhani wanatengenezea ulezi. Hapa sizungumzii mbege ile ya Wachaga, nazungumzia mataptap. So how are they making mataptap? Wakati nakuwa nilikuwa sijui kwa nini wanafanya vile. And even today I hope when I ask my mother, she don't understand why she did that. Na haelewi mpaka leo kwa nini anafanya vile. But when I came to study biochemistry, I became knowing kwamba kwa nini huwa wanafanya vile. While making mataptap, wanaloweka mahindi. Wanaloweka mahindi kwenye maji, then after 2 days wanatoa yale mahindi, wanayasambaza mahali, kama ni kwenye mifuko, kwenye matubai wanayasambaza. Then wanayafunika na kama makaratasi vya ambayo yatakuwa na make sure kuna temperature fulani. Remember the conditions for seed germination. We need to have water or moisture, we need to have air, and we need to have temperature. One among the conditions for seed germination is temperature. So our parents there, they know kwamba mahindi yasipokuwa na joto hayaoti, but they don't know one among the conditions for seed germination is temperature. Unaona? So wanaweka environment fulani ambayo ita make sure kwamba mahindi yataota. Yakishaanza tu kutoa mizizi, wanakuwa na yakagua baada ya siku. After almost 2 to 3 days yanaanza kutoa mizizi. Yakishaanza kutoa mizizi, yametoa radical kabla hajatoa plumule, yani ya majani. Yametoa ile ya mzizi, radical ambayo huwa inaanza kutoka ya mzizi kabla ya majani, yani plumule. Kabla hajaanza kutoa plumule, yakitoa tu radical, mizizi kishakuwa imetoka pale, wanachukua ile mahindi wanaenda wanayaanika. So they don't understand the mechanism behind. Lakini mechanism behind ni nini? Ni kwamba tayari yale mahindi yanapokuwa yameanza kujeminate, kuna enzyme katika mwindi ambayo tutaenda kuielezea kwenye growth vizuri kwamba hizo enzymes zinatoka wapi. Tumechukua mbegu ya mwindi, tumeipanda, enzymes zinatokea wapi? Kwenye topic ya growth tutachambua vizuri na tutaona hizo enzymes zinatokea wapi. Always huwa kuna enzymes katika mwindi ambazo zinavunja ile starch, zina convert kwenda kwenye maltose. So by the time wanaenda kuyaanika mahindi na kuyafanya ya stop the process ya kufanya ya kuendelea kuota, manake wanayaanika yanakauka. Kwa hiyo stop ya kuota inaishia pale. Lakini remember now, in the maize grains we don't have starch again, we have maltose. Baada hapo wanaenda wanayasaga yale mahindi. Wakishasaga, huku upande wa pili wanatengeneza kitu fulani ambacho kinaitwa kichachusha. Kile actually I forget in our language how we call it. I grew in Songea, so nilikulia Songea na nimesahau kwa lugha yetu wanaita I try to recall it, but so when they made that, wanatengeneza kitu kingine ambacho wanakitengeneza kwa ulezi. Wakishakitengeneza kile kinatengeneza kama yeast. Actually sio yeast kama hii ya mila, lakini kinaozeshwa. Kikishaozeshwa chenyewe kina uwezo sasa wa kuconvert ile maltose, kwa sababu ile maltose, ule unga ukishachukua wanaupika unakuwa uji. Unaona? Wanakuwa uji. Ukishakuwa uji mzito, ule uji mzito kwa lugha yetu tunaita nyuru. Unaona? Ule uji mzito basi they take it and then they mix with that composition ambayo ilikuwa imetengenezwa ili kuweza kufanya alcohol au ili kuweza kufanya fermentation of that maltose. So it's a very enjoyable phenomena. I enjoyed it during my growth and I didn't understand what is the mechanism behind. But I am happy that today when I am explaining to you, you even understand kwamba what does it mean. And kama umekulia mazingira ya sijajua, other students which are listening to me, they are coming from different places. Some of them they are born in Dar es Salaam, they don't know about mataptap. But for we ambao tumezaliwa kijini, I hope you have enjoyed this part. Now that is one among the application of the knowledge of biochemistry in our daily life, ambacho tunakuwa tunakijua. So I don't teach you to go and produce alcohol and start drinking. Usije ukawa ni mtu ambaye utakuwa ni hatari sana duniani. Kwa hiyo sikufundishi hivyo. Mimi sikufundishi hivyo. Kwa hiyo just tuendelee tu na biochemistry. Mimi sikufundishi uende ukatengeneza na wewe pombe mahali ili uweze na wewe kuona jinsi ambavyo tunafanya experiment kama hizo. Experiment kama hizo haziruhusiwi kwa wenye umri chini ya miaka 18. Hata kama una miaka zaidi ya 18 basi sio nzuri sana kuzifanya. So nilikuwa naweka sawa baadhi ya mambo hapa. Okay, let's put them well and then we continue. Fine, we are continuing. Kwa tuendelee. Tunaendelea na mwisho tulikuwa naelezea kuhusu maltose. Maltose is formed when two alpha glucose units combine. Alpha glucose units combine with the removal of one water molecule and the formation of alpha 1,4 glycosidic bond. Formation of 1,4 glycosidic bond. But we can say this as alpha 1,4, it is because imetokana na combination of two alpha glucose molecule. So now na formation of glycosidic bond. When maltose is formed, the hydrogen from carbon 1 of one glucose molecule combining with the hydroxyl from carbon 4 of another molecule to form a water and leaves a 1,4 glycosidic bond. The anomeric carbonist 1 of one glucose molecule is free. Hence maltose exhibits reducing property as other reducing sugar. We can see the reactions here for formation of maltose. Hydrogen from carbon number 1 of this glucose combining with the hydroxyl from carbon number 4 of this glucose, forming this maltose molecule having two sugar units and a 1,4 glycosidic bond here. But I hope you will be still remembering kwamba hapa huyu alikuwa ni carbon mwenye aldehyde group na huyu ni carbon mwenye aldehyde group. So we have carbon with aldehyde group here and another carbon with aldehyde group here. So kilichopo ni kwamba katika hawa carbon ambao wanakuwa wana aldehyde group, katika hawa carbon ambao wanakuwa na aldehyde group, huyu na huyu, one of the carbon ambayo ni carbon number 1 of this glucose molecule is involved in the formation of glycosidic bond, while another carbon ambayo ni huyu hapa, carbon number 1 of another glucose molecule, it's not involved in the formation of the glycosidic bond. That is to say, this carbon, it has free aldehyde group, and since it has free aldehyde group, the free aldehyde group enable this carbon to act as the reducing carbon. Kwa hiyo lazima unajua vitu kama hivi hapo kwamba tunaweza tukawa tuna free aldehyde group ambayo inaweza kufanya sasa maltose aendelee kuwa reducing sugar. You know, in sugars like sucrose, we don't have carbon like this. So kama hatuna carbon kama hiyo, manake sucrose is the non-reducing sugar, wakati kwenye maltose it is reducing sugar. Why is it reducing sugar? It's because katika maltose tunakuwa tuna one carbon ya aldehyde ambayo inakuwa still free, so that one carbon in aldehyde which is still free enable the formation of enable the reduction, and when it enables the reduction inafanya sugar wetu awe ni reducing sugar. So that was the discussion regarding maltose. Now here below we have the reaction for the hydrolysis of maltose. I hope you can see this kwamba maltose in the presence of a certain enzyme are always amylase in the living body, or if in the laboratory we use dilute HCl, we can mix with water, then we heat, we get two glucose molecules. Here we have hydrogen, here we have hydroxyl. This is just hydrolysis of maltose releasing two alpha glucose molecule. So let I end up here. In the coming session we start discussing about lactose. Lactose, the milk sugar. Hii ni sugar ambayo iko katika maziwa. I discuss lactose, and then after finishing lactose tutaangalia mpango wa kwenda kudiscuss kuhusu nini? Sucrose. So that's all I can tell you, and this marks the end of our session. And I hope we shall meet another time ambayo tutakuwa tunaenda kudiscuss kuhusu sucrose. So don't forget to subscribe our channel just the only way to support us. So these sessions, they are free. You can simply subscribe our channel. You can share the link of this video to your fellow students, and you can notify more people, telling them kwamba kuna sessions za biochemistry ambazo unaweza kuzipata, sessions za biochemistry na topic nyinginezo ambazo unaweza kuzipata for free. Just ni kwenda tu kuwa na kifurushi chako gigabytes kadhaa, unakwenda na gigabytes zako, and after having that bundle unakuwa unasoma very easy. Unakuwa unasoma wewe tu kuwa na bundle, unakuwa unasoma topic mbalimbali kwa ubora wa hali ya juu kabisa. So I am Dr. Mlelwa, and I wish you nice studies. Let's meet next time. Thank you.